Hey guys, so today we are going to be doing standard 57, which is negative exponents. The comic you see here will make a lot more sense after you watch the video, so come back and look at the screen again at the very end. It might be a good way to help kind of keep these ideas in your head as well. Okay, so first we're going to define negative exponents. So negative exponents are any non-zero real number raised to a negative power. So that would be a non-zero real number would be like the number 4 raised to a negative power. That's just taking any old power, like let's say squared, and instead of just being a 2, it's going to be a negative 2. So that negative exponent, a to the n, is the reciprocal of a to the n. So reciprocal is a word we haven't really heard that often, but we should know what that means. Reciprocal is if I take a fraction and I flip it. So with that being said, a to the negative n is the same thing as 1 over a to the n. And 1 over a to the negative n is the same thing as a to the n. So be sure that you have these written down in your notes. When you do, go ahead and keep going. So if we look at this first example, we have 4 to the negative third. I'm going to refer back to this first part of my definition. So if I have 4 to the negative third, I know that that's going to be the same thing as 1 over 4 to the positive third. So when I do set this up, I need to be sure that I have my positive exponent in the denominator. Alright, if we look at b, this time I have 1 over x to the negative fourth. Okay, I'm going to look at the second part of my definition. So when I turn this into a positive exponent, what I'm going to do is I'm going to put x to the fourth on top over 1. Now we don't need to show that we're dividing something by 1, so I can rewrite this as x to the fourth. And that's our final answer. So this is a quick introduction to what negative exponents look like. When we go to the next example, you're going to see a little bit more going on. But before we do, I want to talk about what it means to be completely simplified in these problems. There are 4 things that we need. The first, we only want positive exponents. That's why we're going to learn how to go from negative exponents to positive exponents. So if you have negative exponents, you are not simplified. Only positive exponents. Second thing, each base appears once. So I should not see my variables more than once. Whoop. Third thing, no parentheses. We don't want any powers of powers. There should be absolutely no parentheses in your final answer. And then finally, all of our fractions are simplified. So if you go through those 4 things right there to make sure that you have a simplified answer, you should be golden. Okay, so go ahead and pause the video, try these out if you'd like, and then we'll go over these together. Alright, so if we look at A, the first thing that I'm going to do is I'm going to circle any of my bases and their positive and their negative exponents. So in A, I see 2 negative exponents. I see n to the negative fifth, but I also see r to the negative 2. So what I'm going to do after I circle my negative exponents, I'm going to go ahead and redraw my fraction bar. Any exponents that were on the top of my fraction stay on the top that were not circled. There is a p to the fourth on top, that's still going to be on the top of my fraction. Anything that was on the bottom that was not circled stays on the bottom. I don't have anything circled on, or anything not circled on the bottom. So now I go to my negative exponents. I had an n to the negative fifth on top, but I know in order for it to be positive, I need to move it to the bottom and make that exponent positive. So what I'll have now is an n to the fifth in my denominator. And I'm going to do the same thing with r to the negative 2. I'm going to move my negative exponent to the top, which then makes it positive. So what I have is r to the positive 2 in my numerator. I check, do I have any negative exponents? Nope. Do I have any parentheses? Nope. Do I only see each base once? Yes, I do. Do I have any fractions to reduce? Nope. This is simplified. Alright. B is just a little bit harder. Again, I'm going to start by circling any of my bases with negative exponents. So that's going to be my r to the negative 3, and I have a u to the negative 5 in the denominator. Okay, I'm going to write my equal sign and draw my fraction bar. Anything on top stays on top. So I have about 5t to the 4th that were not circled. And in the denominator, I have negative 20r squared t to the 7th that were not circled. Now I'm going to look at my circled exponents. R to the negative 3, in order for it to be positive, I need to move it to the denominator. So I'll have r to the positive 3. Be sure you change the sign on your exponent when you switch which side of the fraction it's on. I had a u to the negative 5th in the denominator. I'm going to go ahead and move that to the numerator, and it's also going to become a positive exponent. So now I'm going to go through my checklist to see if I'm simplified. Do I have any negative exponents? Nope, so that's good. Does each base appear only once? Now that is not true. I have a t in my numerator, a t in my denominator. I also have 2 r's in my denominator, so I need to combine those using other rules. Okay, so I'm going to go ahead and start with the t in the numerator and t in the denominator. I know that if I were to write this out, I would have 4 t's. Actually, let's go ahead and just write this out. What we have on the top is 5. T to the 4th is the same thing as t times t times t times t. And then u to the 5th is going to be, well, it's the only base of u, so I'm actually just going to rewrite it as u to the 5th power. In my denominator, I have negative 20. And then r times r for r squared, t times t times t times t times t times t, 1, 2, 3, 4, 5, 6, 7 t's, and then 3 r's, 2, 3. Okay, so this is going to combine a few different properties. I'm going to go ahead and cross out my t's on the top and on the bottom. So I have 1 here, 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 1 here. And I'm going to see on the bottom, I'm going to need to multiply together all of my r's. And what I'll end up having on my top, there are no t's left, but I do have a 5 and a u to the 5th. In my denominator, I have negative 20. The total number of r's that I have at the bottom are 1, 2, 3, 4, 5. So that'll give me r to the 5th. I crossed out 4 of my t's, and I'm left with t being multiplied by itself 3 times, which gives me t to the 3rd. Okay, so now if I look at my new answer, I only see each base once, and so finally we need to talk about simplifying fractions. So I am going to treat this 5 over negative 20 as the fraction that it is, and I'm going to reduce it. So both the top and the bottom can be divided by 5. So what that's going to give me when I divide my top by 5, I'll have a 1 times u to the 5th. And when I divide my denominator, that negative 20 by 5, I get negative 4 r to the 5th t to the 3rd. This is my simplified answer. All right, let's go on to C. So once again, we're going to start by circling any negative exponents that we see. I have lots in this one. Okay, I'm going to redraw my fraction bar. Anything that was on top not circled stays on top. So 2a squared, b to the 3rd. And in the denominator, it's just going to be the 10 that stays. All right, so my c to the negative 5th was on top. I need to move that to the bottom and make it positive. A to the negative 3rd was in my denominator. I need to move it to the top to make it positive. So I'll have a to the 3rd. B to the negative 1 needs to go to the top, so it'll have b to the positive 1, and c to the negative 4 goes to the top, so it's c to the positive 4. Now I need to go ahead. I see my bases several times, so I'm going to go ahead and use my properties to combine them. So on the top I have an a squared and I have an a to the 3rd. I know that since they have the same base and they're being multiplied, I can add their exponents and I'll have a to the 5th. I also have b to the 3rd, b to the 1st, so that ends up being a b to the 4th. And then I can just rewrite my c to the 4th on top, and on the bottom I'll have 10 c to the 5th. So I still see a c on top and a c on bottom. So I'm going to go ahead and use my quotient properties where I'm going to subtract my exponents. So on the top I'll still have 2a to the 5th, b to the fourth. But now if I have 5 c's on bottoms and 4 c's on top, that means all my c's on top are going to go away, and I'll be left with 1 on the bottom, giving me 10 c to the 1. And now I just need to look at one last thing, which is my fraction, 2 over 10. That can be reduced. And when I reduce that fraction, it'll give me 1/5. So on the top, I'll have a to the 5th, b to the 4th, all over 5c to the 1. And this is our simplified answer. Alright, so go ahead and pause the video, write down A and B, try these on your own. I know that this seems a little difficult. It's putting a lot of our properties together, but I have faith that you guys can do it. Write down any questions you have and bring them to class tomorrow.